Okay, this is a pre-video for section 2.3. I'm going to cover the first two concepts in this section to get us ready for class coming up next week. These are things that are extensions of pretty much things we've already learned this semester, but we're kind of tying them into now solving the equations. So if you remember, we talked briefly in class last week about quadratic equations are the equations that have x squared as their highest power. So definition is an equation that can be written in the form ax squared plus bx plus c equals 0, where a has to actually exist. So you do have to have the x squared term. It doesn't matter if you have b, c, or both, or one of those, but you have to have the ax squared. So here's some examples of different ones. Notice this doesn't have x squared, but if you distribute, it actually does. So that is just variations of that. There are 4 ways to solve a quadratic equation. In this video, I'm going to focus on number 1 the most because that is something we've already practiced a lot of, which is the factoring. We're just going to show you now how to solve the equation. I'm also going to briefly touch on the square root method because it is just a special scenario, but it's crucial because it is how we will then in class complete the square. And then the last one, of course, is quadratic formula, which we will teach you in class this week. So if you want to solve by factoring, the first thing is you have to get everything on one side and have it set equal to 0, and then you factor it down as far as it'll go. If you have 2 factors or more equal to 0, this is multiplication. So the only way you can multiply and equal 0 is if one of or both of these things was 0. So that's why we're allowed to then set each piece or each factor equal to 0 and solve. That is called the zero factor theorem. So we will get everything on one side, have it set equal to 0, and then we will see what we can solve from that. If you have an answer that appears twice, remember that has a multiplicity, or it's called a double root is another name. So I have 3 examples of factoring here. So let's talk about this first one. The first thing you should always check for, especially since the numbers are so big, is a GCF. Let's see if everything's divisible by 4. I know everything's divisible by 2, but 4 would be easier. Yep. And 324 divided by 4. Yes, so this is going to have a 4 that can get pulled out. That would make that x squared minus 18x plus 81, if I remember what I just used on my calculator. We need factors of 81 that add to negative 18, and they're going to have same signs, so they have to both be negative. That, to me, screams negative 9 and negative 9, because they multiply to positive 81 and they add to negative 18. Because they are identical, you only need to solve one of them. Also, you only solve this piece out front, the GCF, if there's an x attached to it. If it's just a number and you set it equal to 0, 4 equals 0 does not make any sense. So we are just going to solve x minus 9 equals 0. And we only have to solve it that once. You can write a little note if you want to that it has a multiplicity of 2. That means that the solution occurred twice. Let's look at my number B, or part B. You can't solve this one yet because not everything's equal to 0, and you definitely can't set everything equal to 27. That rule does not exist. It has to be equal to 0. So what we have to do in this scenario is actually undo all of their work and move everything over. So this would be 8x squared plus 30x, and then minus the 27 would come over. Now, unfortunately, this does not look like there is a GCF, so we have to do 8 times 27, and that is negative, so it's going to be negative 216. Factors of that are 1 and 216, 2, and we're going to have to go through our list, so divide that by 2, 108. Let's see if it's divisible by 3. Yep, 3 and 72. Is it divisible by 4? Yep, 4 and 54. So this is going to be a long list. It's not divisible by 5. Is it divisible by 6? It should be, since 2 and 3 went into it. So 6 and 36. And actually, I'm going to stop. I know my list could go further, but this pair right here, if one of them was negative, it would multiply to negative 216, and we could possibly make it add to 30 by making the 6 the negative one. So remember, your next step is to factor by grouping. It doesn't matter which one you put first, so I'm going to put the negative 6 first. So negative 6x and 36x came from this 30 and also the fact that it multiplied correctly to the a times c. We would factor by grouping by finding a GCF for each pair. The first pair has a 2 and an x in common. If you divide a 2 out, that would leave you with a 4x minus 3. This pair has a positive in front of it, so that means we pull out a positive, and they're both divisible by 9, and that also leaves me with 4x minus 3. We said, okay, now 4x minus 3 is a match, and the other binomial is the 2x plus 9. And remember, this is still set equal to 0. Do not drop that, or you will forget to solve at the end. 4x minus 3 equals 0, or 2x plus 9 equals 0. When you solve these, you always do opposite operations. So when you move that over, it becomes positive, and then you divide. So 3/4 is one of my solutions. If I subtract the 9 over, that's negative 9, and then I would divide by 2. So the other solution is negative 9/2. For this last one, it's actually reminding us of what to do with a rational equation. We remember we factor everything in the bottom. See, none of this stuff goes away. You have to keep fresh on all of these skills. It looks like my LCD would be x plus 2 and x minus 2. It's important at this point to remember that there are solutions that do not work. Negative 2 would make the first parenthesis 0. Positive 2 would make the second parenthesis 0. If we get these answers at the end, we have to throw them out. And then remember, we're going to multiply each, and I don't have a lot of room, so I'm going to write it in red. We're going to multiply each fraction by those two pieces of the LCD. And x plus 2, x minus 2. In the first one, the x minus 2 cancels, and you get 3x times x plus 2. In the second one, the x plus 2 cancels, and you get positive 1 times x minus 2. In the last one, both denominators cancel, but you do have a negative here, so it's equal to negative 4. We distribute. Combine like terms on this side. And it's not equal to 0 yet, so we have to add that 4 over. So this becomes 3x squared plus 7x plus 2, because negative 2 plus 4 equals 0. Again, it's an AC method, so 3 times 2 is 6. 1 and 6, 2 and 3 has to add to 7, so it has to be 1 and 6. So 3x squared plus x plus 6x plus 2 equals 0. You can pull an x out of the first pair and you get 3x plus 1. You can pull a 2 out of the second pair and you get 3x plus 1 again. So 3x plus 1 is the first parentheses and x plus 2 is the second parentheses. When you solve those, you kind of get to a pattern here. This would be negative 2 because you just subtract 2 over. On this one you would subtract 1 and divide by 3, so that's negative 1/3. A lot of students will circle both of these because they're just happy to get the answers, but remember negative 2 is restricted. This answer is no good, because if you plugged it into the original equation, you would get 2 of these denominators being undefined. So there's only a single solution to this one because you had a solution that did not work. Okay, the only other thing I wanted to cover kind of ahead of time, and I'm not going to do all of these because I want to start off with one of them in class, is the square root method. If you have a quadratic equation and it has to be in a very specific form, that form is something squared equals a number. So whether that be an x squared or an x plus 2 squared, something squared equals a number. And for right now, because we don't know anything about the imaginary numbers yet, our number on the other side needs to be positive. When we get into the section, which is 2.4, which is next right after this one, we'll know what to do with a negative under a square root. So at some point we will be able to solve these for any something squared equals a number. And then it says if that happens, you can take the square root of both sides. The only thing you have to worry about is that because 4 squared equals 16 and negative 4 squared equals 16, when you take a square root, you need to add in a plus or minus. That does not happen every time you see a square root in your life. Anytime you take a square root of both sides, that is when you must add the plus or minus. So here are the rules. Isolate the part that is raised to the second power on the left side. take the square root of each side. Don't forget to write a plus or minus on the right side with the part you just took the square root of. Solve for x. Make sure your radical is simplified. Note, it is common practice to allow one variable to represent more than one value, as in x equals plus or minus 3. Another way of writing that is separating it out into 3 and negative 3. And I believe Webassign makes you separate them out. And not only that, it also wants negative 3 listed first and then 3. It wants it from least to greatest. And it usually will say smallest to largest next to the answer blanks. And this whole method right here of taking the square root of both sides and writing the plus or minus when you have this set up is called the square root method. It is really important to know this because it's going to be part of completing the square. So I'm going to do one of these, just one, and then I'll save the other one to start off the class. So for this first one, we have something squared equals 31, a number. And this number is positive right now, which is good since I don't know anything about what to do with the negatives yet. So the rule says I can take the square root of both sides as long as I put a plus or minus on the side that wasn't squared. This side cancels out because of the square and the square root, so you're just left with the inside, which is x plus 4. This is plus or minus the square root of 31. To finish solving this, x needs to be by itself, so we subtract over the 4. The common practice is to put that number in front of the plus or minus. Now, for Webassign, so I would accept this on the test. This would be cool. I'd be like, woo, good time. On Webassign, they would have you write that two different ways, with the smaller one being first. That means write the negative case first. So negative 4 minus the square root of 31, and then negative 4 plus the square root of 31. That would be how they would want it. All right, that ends this pre-video, and I will see you guys in class next week where we will pick this up, complete the square, do quadratic formula in class, and we'll also start talking about those complex numbers. So have a good weekend, guys.